Today we are working on 6.2. I know what you're thinking. We didn't do 6.1. Sorry, I deleted it. In 6.2, we're going to be graphing rational expressions. And rational expressions all come in some form of curves that are governed by these horizontal and vertical lines we're going to call asymptotes. Let's see if I can spell it. Asymptotes. I have no idea where the word came from. But an asymptote is a line that a graph approaches but never reaches. And you've seen that with exponential equations. So you have a graph that comes down, and over here it gets closer and closer to the x-axis, but it never touches it. So in this case, the x-axis is an asymptote. In rational expressions, we have what we call vertical asymptotes, which I will refer to as a VA, or horizontal asymptote, which we will abbreviate HA. And then our rational expressions are sort of bounded by those two lines. So we might have a rational expression that looks like this. And here, 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 and here, the graph approaches those asymptotes but never reaches it. So today we need to figure out, how do we tell where the VAs are and where do we tell where the HAs are? And it turns out it's actually really simple. So here we have a rational expression. Rational expressions are just fractions where the top is a polynomial and the bottom is a polynomial. So you could have a rational expression that was like x plus 2 over x squared minus 3x minus 5. So I have a linear equation on top and a quadratic equation on bottom. And they can be bigger than that. But today we're going to work on simple stuff. So the easiest to find is a VA, a vertical asymptote. A vertical asymptote occurs anytime the denominator is equal to 0. So any numbers that make the bottom 0 create vertical asymptotes. So here, the bottom is x minus 5. So I set that equal to 0, and I get x equals 5. This number is a no-no. You cannot plug in 5. When you try, you get negative 7 over 5 minus 5, which is negative 7 over 0, and the world falls apart. Negative 7 over 0 is not a number, and it breaks. So I can go ahead and graph my vertical asymptote at 5. So let's see if I can do this from here. I take my vertical asymptote and I put it at 5. Now, the horizontal asymptote shows up in a relationship between the numerator and the denominator. So we're going to look at the strength of the polynomial. So the numerator is negative 7x to the 0, and the denominator is x to the first minus 5x to the 0. And we're only going to worry about the strongest x's. So the strongest x on top is a 0, and the strongest x on bottom is a 1. Anytime the denominator is stronger than the numerator, then your HA is going to be at 0. So if I had a bigger equation, x minus 3 over x plus 2x squared minus 5x, and I identify the strongest variables. The strongest one in the numerator is x to the first, and the strongest one in the denominator is x squared. The bottom is stronger than the top, so the HA is at 0 every time. Now that would also be true if, let's say, the bottom was x to the third. So here is the strongest one, and the top has an x squared. X to the third on bottom is more powerful than x squared on top, so the HA is the x-axis. What happens when the top and the bottom are the same strength? So the top is an x squared and the bottom is an x squared. The asymptote will be the fraction of these two terms. So I take 1x squared and I divide it by 2x squared. The x's are going to cross off, and I'm left with the number 1/2. That means that the horizontal asymptote is y equals 1/2. So if the bottom is stronger than the top, the HA is at 0. If the top and the bottom have the same strength, then we just look at the numbers in front of those and divide them, and that gives us our HA. So let's do another problem. Okay, so this one, I set the bottom equal to 0, add 6, negative 4x equals 6, divide by negative 4, and I get x equals negative 1.5. So my VA, my vertical asymptote, is at x equals negative 1.5. For the HA, I look at how strong the numerator and the denominator are. The top is an x to the 0, and the bottom is an x to the first. The bottom is more powerful, so the HA is y equals 0. It's on the x-axis. All right, let's move to the next one. Same idea. Find the vertical and horizontal asymptotes. So I set the bottom equal to 0, add 7, and divide by negative 2. So x equals, what is that, negative 3.5. I have an HA at negative 3.5. Now, you're going to have to use the coordinate button to make this work. It probably won't let you drop an asymptote at negative 3.5. So you'll have to pick 2 points, or maybe just 1 point, I don't know. And I would say those are both bad points. So I could pick this point right here, negative 3.5, comma 1. And if you drop that point, it might let you drop that vertical asymptote. If not, you'll have to pick another point, negative 3.5, comma 3. And then put your vertical asymptote right there. For the horizontal asymptote, we look at the strength of the bottom and the top. The top has an x to the first, and the bottom has an x to the first. So they are equally powerful. We cross the x's off, and I'm left with negative 2 divided by negative 2. Notice these numbers don't matter when you're talking about horizontal asymptotes. So negative 2 divided by 2, negative 2, is 1. So we have an HA at y equals 1 right here. Okay, let's do another one of those. All right, the bottom set equal to 0. We get negative 10 over 4, which is negative 2.5. So again, you're going to have to use this button to pick a point or two so that you can drop your HA or your VA at negative 2.5. And then we look at the numerator and the denominator. They're the same strength, so we cross that out. I'm left with y equals negative 6 over 4, which is negative 1.5. That's an HA. So I drop a couple points at negative 1.5 and then draw my asymptote. The next two problems are almost the same, except you have to draw the graph as well. So now we have the equation negative 4 over x plus 2. So set the bottom equal to 0, we get x equals negative 2. That is my VA. The bottom is stronger than the top, so the HA is y equals 0. I draw those. I draw a VA at negative 2, and I draw an HA at 0. Now it says, plot 2 points on each piece of the graph. So we sort of have 4 areas. And vertically, a rational expression can only show up in one of the 2 areas. So there's going to be one piece of the graph here and one piece of the graph here. We just need to figure out where they are. So we need to pick 2 points on this side. And you can pick any number you want as long as it's not a vertical asymptote. So I could choose the numbers, let's say I choose -3 and -5. So I plug those in. -4 over -3 plus 2. I'm just putting -3 in there. That gives me -4 over -1, which is 4. So I put a point at -3, 4. So -3, 4. There's a point. Okay, and now let's plug in -5. -4 over -5 plus 2. That's -4 over -3, which simplifies to be 4/3. So 4/3. I use the coordinate plotter, and I type in -5 4/3, which is like 1 1/3, so it would be right here. So now I have 2 points on this side. Now I need to choose 2 points over here. Whenever possible, well, not whenever possible, but it's often a good idea to choose -1 or 0 or 1. Those are usually really easy numbers to plug in. Or you can look at the equation and you can say, what number would make that easy? Well, in this case, 2 would be a really nice number. So if I plug in 2 comma something, I get -4 over 2 plus 2, which gives me -4 over 4, which is -1. So 2, -1 would be right there. You can't always find a number that's nice, in which case you have to use the coordinate plotter to type in the fractions. But if I tried 0, I'm not going to get a fraction. So 0 in this case is a really good idea, although any number on that right side would work. So -4, well, so I want 0. -4 over 0 plus 2 is just -2. So I need to plot the point 0, -2, like that. Once you have all of those plotted, you push this button and it will draw the graph for you. Oh, I messed up my asymptote, sorry, like this. All right, let's do one more. Same instructions. Set the bottom equal to 0. So my vertical asymptote, subtract 3, I get x equals -3. Okay. For my HA, I check the strength of the numerator and the denominator. The numerator and the denominator have the same strength. I cross off the x's, and I'm left with 2 over 1. So my horizontal asymptote is y equals 2. I draw those. So I drop my horizontal asymptote on 2. I drop my vertical asymptote on -3. And now I start plugging in numbers. So I need 2 numbers over here. I'm going to try -4. So I'm going to graph -4 comma something. To get that something, I put -4 in here and in here. 2 times -4 plus 3 over -4 plus 3. So the top gives me -8 plus 3 is -5. And the bottom gives me -4 plus 3, which is -1. And that simplifies down to 5. So -4, 5, that's my first point. And then let's try -5. I don't know what's going to be a nice number. -5 comma something. 2 times -5 plus 3 over -5 plus 3. The top is -10 plus 3, which is -7. And the bottom is -5 plus 3, which is -2, which simplifies down to 3.5. So 3.5. I use my coordinate plotter. -5 comma 3.5 would be right here. So now I have 2 points on the left. Now I need 2 points on the right. And looking at this equation, zeros would be really nice. If I type in 0, I end up with 3 divided by 3, which is 1. So 0, 1 right here. Okay. I'm going to plug in -2. See what happens. So it will be -2 comma something. All right. What is the equation again? 2 times -2 plus 3 over -2 plus 3. So the top gives me -4 plus 3 is -1. And the bottom gives me -1. So that simplifies down to be 1. -2, 1. Hold on, something's not right. 0, 1. What did I do wrong? Oh, the bottom is +1. Sorry. So -1 divided by 1 is -1. So -2 comma -1 right there. Now I push the graph button and it should draw my rational expression. Looks like that. All right, that's it for today. Get to work.